Hey everyone, and welcome to This Explainer. I'm so glad you're joining us today because we're going to talk about something that literally runs the modern world, even though it mostly happens totally behind the scenes. We're talking about the data assembly line. So today we're unpacking the core functions of data processing, the exact step-by-step ways we take raw, totally chaotic data and transform it into sharp, actionable intelligence.
It all really kicks off with one massive question, right? I mean, think about it. Every single day, businesses and organizations are collecting absolute mountains of numbers, text strings, and just unstructured facts. But on its own, raw data doesn't actually confer any meaning. It's just noise. So how in the world do we actually make decisions out of all this raw, chaotic data? How do we build a system that takes in a total mess and spits out pure clarity? Well, we send it through a very specific 5-step pipeline.
Okay, let's dive into this roadmap. Think of these 5 core functions as consecutive stations on an assembly line. 1. Validation. 2. Sorting. 3. Aggregation. 4. Analysis. And 5. Reporting.
All right, let's head to our very first stop. Station 1, validation.
So before we even think about organizing anything, we have to make absolutely sure the data we just collected is actually supposed to be there. The UNECS glossary officially defines data validation as an activity aimed at verifying whether the value of a data item comes from a given set of acceptable values. Basically, you can think of this function like a bouncer at the door of an exclusive club. The bouncer has a list, and if your name, or in this case your data value, isn't on that list of acceptable values, you simply don't get in, period.
So the crucial point here is captured perfectly by a 2013 quote from Simon. He noted that data validation could be operationally defined as a process which ensures the correspondence of the final published data with a number of quality characteristics. Make sense? If our initial data is flawed, our final outcomes will be totally off too. Validation just guarantees that by the time this data reaches the very end of our assembly line, it has exactly the quality characteristics we need to actually trust it.
All right, our data made it past the bouncers. Now it moves on to station 2, sorting.
Even though it's validated, our data is still kind of just a big jumble at this point. Sorting is any procedure that organizes data into a meaningful order so it's simpler to comprehend, analyze, and visualize. Software programs usually do this by sorting actual numbers, counts, or percentages in ascending or decreasing order. But get this, they can also sort based on variable value labels. That's essentially metadata hiding in certain applications that lets researchers save labels for each value alternative in a categorical question. By applying these sorts, we start to actually see the story the data is trying to tell us.
To see how this works in practice, just know that data sets can be sorted by multiple factors at the exact same time. For instance, you could have a primary sort organizing everything by region, followed immediately by a secondary sort by country. So within each neatly sorted region, that country sort kicks in, right? It takes what used to be a totally random pile of records and turns it into a highly logical, easy-to-follow structure.
With everything beautifully organized, we arrive at station 3, aggregation. This is the step where we shrink all those detailed individual rows down into highly efficient summaries. Think about the massive difference between raw data and aggregated data. Raw data is made up of individual data rows, usually scraped together from several different sources, but when data is aggregated, those individual rows get replaced with summaries, totals, and statistical observations. Why bother doing that? Well, efficiency for sure. A data warehouse relies heavily on aggregate data because it drastically cuts down the time required to query massive data sets. Instead of sifting through millions of separate rows, the system just reads the aggregated totals and instantly gives you answers to analytical inquiries.
Okay, now we're entering the real brain of the operation. Welcome to Station 4, analysis.
Everything we've done so far, the validation, the sorting, the aggregation, that was all just prep work for this exact moment. The ultimate objective of data analysis is to extract relevant information so we can make actionable business decisions. To get that business intelligence, the analysis process requires 3 main actions: cleaning the data, converting the data, and modeling the data. By putting the information through those 3 steps, an analyst can finally pull out the high-value insights needed to guide major organizational choices.
Now, what's really interesting about this is how natural this concept is to us as human beings. We actually do data analysis in our day-to-day lives all the time. Seriously, every single time we make a decision, we think about what occurred previously or what would occur if we chose a specific option. We are literally just studying the past or the future and basing our judgments on that analysis. We do it by recalling our history or imagining our future.
That complex commercial task an analyst is doing in a corporate office, it's exactly the same fundamental process, just supercharged with software.
Which brings us to the final stop on our assembly line, Station 5, reporting.
Look, having actionable intelligence is amazing, but it's basically useless if it just stays locked inside an analyst's laptop, right? Data reporting is the act of gathering and structuring that raw data and turning it into a consumable format so the organization can evaluate its continuous performance. These reports are built to answer fundamental inquiries about the status of a firm. It could be as simple as showing data in an Excel document, or maybe a basic data visualization tool. Usually, static data reports will use the exact same structure over time and collect data from a single source just to keep everything consistent.
Ultimately, a finished data report is nothing more than a set of documented facts and numbers. Consider a population count, for example. That's a technical paper conveying basic facts on the population and demographics of a country. It might just be text, or it could be highly visual with graphs and charts, but however it looks, this static information is utilized to evaluate present situations and actually drive decisions. It is the ultimate finished product of our entire data assembly line. And that brings us to the end of the line. We've taken chaotic data, checked it at validation, organized it with sorting, summarized it through aggregation, pulled out the insights during analysis, and packaged it all up perfectly in reporting. So I want to leave you with this final thought. What actionable decisions will you make with your newly processed data today?
Okay, today we're taking something that usually sounds like a highly technical IT headache, data classification, and transforming it into a seriously clear strategic framework for your organization. I am absolutely thrilled to guide you through this because once you really grasp how this works, it's going to completely change how you view the information flowing through your business. Let's dive right in. Now, to get started, I want you to imagine your organization's data as a massive, completely chaotic physical warehouse. I'm talking boxes piled straight up to the ceiling, absolutely nothing is labeled, and literally anyone can just wander in and open whatever they want. Trying to find a highly sensitive contract in there? Yeah, it's way worse than a needle in a haystack. Think about how much that chaos is actually costing you. And honestly, how terrifying is it that someone unauthorized might stumble upon it first? Well, that is the harsh reality for organizations that lack proper data classification. It leads to huge storage costs, agonizingly slow search times, and just massive security risks. So, to fix all this chaos, here's our roadmap for today. 1. Decoding data classification. 2. 3 industry standard methods. 3. The 3 risk categories. And 4. The classification process steps. All right, part 1, decoding data classification. Let's look at what this actually means. While the term itself might sound hyper-technical, data classification is really just intelligent labeling. Simply put, it's the process of classifying data into important categories so that it can be utilized and basically safeguarded far more effectively. You're labeling information to make it totally searchable and trackable. And I really want to stress this point right out of the gate. While it obviously involves technology, this is absolutely a topic that your organization's leadership must comprehend. It's not just an IT problem, It's a foundational business strategy. And on a fundamental level, this intelligent labeling translates into some massive operational efficiencies. By actually classifying your data, it makes everything easier to identify and access, which totally prevents those massive duplications of data we see all the time. Think about it. If you aren't saving 5 copies of the exact same file everywhere, you drastically minimize your storage and backup expenses. Plus, it really accelerates your search procedures. And crucially, when we're talking about risk management, compliance, and data security, classification is of special relevance. Because at the end of the day, you literally can't protect what you haven't identified. Moving on to part 2, 3 industry standard methods. Here's how we actually tag all this information. The first method is content-based classification. Think of this as the system literally reading the document for you. It examines and interprets the files directly, hunting for sensitive data. So, for example, if a file contains a string of numbers formatted perfectly, like a credit card or a social security number, boom, the system automatically flags and classifies it based purely on that literal content. It's very direct and it's totally automated. Then we have our second method, which is context-based classification. Now, instead of looking at what's actually inside the file, this method looks at the circumstances surrounding it. It uses indirect markers. What application created this? Where exactly does it live? Who is the creator? If a document is pumped out by your payroll software and saved right into the HR department's restricted drive, the system uses that specific context to classify it as sensitive, completely regardless of the specific text inside it. And the third method really puts the power, and let's be honest, the responsibility, right into the hands of the end user. User-based classification relies on the actual human selection of each document. It depends on human expertise and judgment during the creation, editing, review, or distribution of a document to indicate if it's sensitive. You've probably seen this yourself. Whenever you go to save a file or send a really important email, and that familiar little prompt pops up asking you to select whether it's public or confidential, that is user-based classification in action. All right, part 3, the 3 risk categories. This is where we assess data risk. So once we know how to classify, we really need to raise the stakes here because, let's face it, not all data is created equal, right? It's standard practice to divide things up into 3 risk categories. Low-risk data is essentially accessible to the public. If it's lost, recovery is super simple, so it poses a much smaller risk. Things like public data sets or marketing materials. Then we have moderate-risk data. This is basically non-public or internal data. Think proprietary operating processes, product costs, corporate paperwork. It's not public, but it's unlikely to be incredibly mission-critical either. High risk, on the other hand, is anything even vaguely sensitive or critical to operational security, or data that would be incredibly difficult to retrieve if you lost it. Secret data, essential operational info. Categorizing all this into these 3 buckets tells you exactly where you need to spend your security budget. Now, for larger firms dealing with just massive volumes of data, using a data classification matrix becomes absolutely essential. This kind of setup maps out the exact impact on the institution if data is compromised. It clearly defines the risk, and it dictates exactly who should have access, from the general public down to designated individuals only. Having a matrix like this enables you to rapidly identify how likely your systems are to be hacked and exactly how to safeguard everything you've got. Which brings us to part 4, the classification process steps. Here is your implementation roadmap. Implementing this effectively really requires a clear 3-step roadmap. Step 1. Understanding your current setup. Honestly, before you can classify data, you absolutely must know what data you actually have. Taking a comprehensive look at the location of your organization's current data and any applicable legislation is definitely the best starting point. Step 2 is priority number 1 for compliance, the creation of a data classification policy. Without an adequate policy, maintaining compliance with data protection standards is practically impossible. And finally, step 3, prioritize and organize the data. Now that your policy is officially in place, it's time to categorize everything based on sensitivity and privacy, and ultimately choose the optimal method for tagging it all. And that brings us to the end of our explainer. But I want to leave you with this provocative thought to help evaluate your own organization's readiness. Is your data a neatly classified, easily searchable strategic asset? Or is it kind of like that chaotic, completely unorganized warehouse we talked about at the very beginning? Just a massive operational liability waiting to cause a security breach. I highly encourage you to champion these classification steps within your own leadership teams.
We're talking about the sheer, mind-boggling volume of data that institutions have to process, store, and ultimately protect. Now, look, if you're a small company, data creation and labeling, it's pretty simple. If your firm doesn't juggle a ton of data types or you just process fewer transactions, figuring out your system's risk is pretty straightforward. But for businesses working with massive volumes or just a dizzying array of data types, totally different beast. They desperately need a thorough, structured method for assessing their risk. Okay, let's dive into this.
So how exactly do businesses assess data risk at scale? Like I said, small shop, easy. But when you're a massive institution handling thousands of transactions, personal files, and proprietary secrets, you absolutely cannot just guess. You need a highly reliable system to gauge the likelihood of getting hacked, and even more importantly, you need to understand exactly how sensitive that data is if it ever does fall into the wrong hands. You basically need a map.
And here is our map for today. We'll start with the data categorization matrix itself. Then, we'll break down the 3 distinct tiers: high-risk confidential data, medium-risk sensitive data, and low-risk public data. Finally, we'll wrap up with how all of this actively safeguards institutional integrity.
Starting right off with Section 1, the Data Categorization Matrix. This framework is essentially the ultimate solution for identifying exactly how to classify and safeguard sensitive information across an entire enterprise. To make this super easy to picture as we go along, I want you to think of this matrix kind of like a highly exclusive VIP club.
So what is it? A data categorization matrix is a tool that rates data and systems based on 2 absolutely crucial factors: how likely they are to be hacked and just how sensitive that data really is. By building this out, an institution empowers itself to rapidly identify where its true vulnerabilities lie. It completely takes the guesswork out of data protection. Instead of treating all data equally, which is, frankly, wildly inefficient and expensive, you classify it and safeguard it based on its specific matrix rating.
And this brilliantly illustrates exactly what we're talking about with a sample risk classification matrix. Notice how it's structured. Across the top, we have the risk levels: high, medium, and low, which map directly to confidential, sensitive, and public data. Then, breaking it down further, it evaluates the institution impact, provides a detailed description, and outlines the strict access rules for each of those tiers. We are going to break down this exact structure step by step, starting with the absolute most critical level.
Which brings us to Section 2, High-Risk Confidential Data. This is the top tier of our matrix. Going back to our metaphor, this is the ultra-secure vault of our data venue. The stakes here are incredibly high, and the rules completely uncompromising.
For high-risk data, access absolutely must be controlled from the exact moment of its creation to its ultimate destruction. We're talking about highly sensitive data that often involves deep personal privacy considerations. It might even be restricted by strict federal and state laws. This also includes information that provides access to physical or virtual resources. You literally cannot afford a single slip-up here, from generation to permanent deletion.
If we look at the core pillars here, the negative impact on the institution if this high-risk data is incorrect, improperly disclosed, or simply unavailable when needed is generally very high. Because of that severe impact, access is restricted strictly to designated individuals with approved access. Usually, this means people affiliated with a university or institution who require it to actually perform their jobs, or individuals explicitly permitted by law. There are no exceptions here.
To really drive that home, access to confidential data must be individually requested and then authorized by the Functional Security Module representative. That representative is the specific person personally responsible for the data. This means absolutely no blanket access is allowed. You can't just hand the keys to an entire department. It requires specific, individual, case-by-case authorization.
Let's move along and see how this builds as we transition from high risk to medium risk. It's really fascinating to watch how the rules shift. High risk requires individually requested access strictly for specific personnel, but medium risk, that shifts to role-based access, meaning it can actually be authorized to groups of people based on their job classification or responsibilities.
And that segues perfectly into Section 3, Medium Risk, Sensitive Data. This is our VIP lounge. It's internal, non-public data. So it definitely isn't public, but it's not locked down entirely in the vault either. It's a much more balanced, measured approach.
Medium risk involves moderately sensitive data. The key takeaway here is that this kind of internal data is often used for making operational decisions. Because it actually drives the business forward, it is crucial that this information remains both timely and accurate. If this data is locked down too tightly, the business basically grinds to a halt. The organization needs this data flowing to the right people so they can make informed, rapid decisions. Now, if this internal information is unavailable, there's a moderate risk for negative impact on the institution. Access still has to be requested from and authorized by the Functional Security Module representative, but it can be limited by one's employing unit or affiliation, that role-based access we just talked about. As an example, looking at Eastern Michigan University, or EMU, access here includes EMU employees and even non-employees, provided they have a legitimate established business need to know.
Next up is Section 4. Low-risk public data. We are now officially entering the general admission area of our data matrix. Here, the entire focus shifts away from secrecy and lockdown to something else entirely, maintaining data integrity.
There's a fascinating nuance here. Public data is published with literally no restrictions. It's not considered sensitive at all. But just because it's public doesn't mean it's ignored. The integrity of this public data must still be protected. The appropriate Functional Security Module representative actually has to authorize the replication or copying of this data to ensure it remains accurate over time. Because think about it, you really don't want outdated or corrupted public data representing your institution out in the wild.
If this public data goes unavailable, the institutional impact is typically low, maybe a bit inconvenient, but certainly not debilitating. Because it's published without restrictions, access can be granted to any requester. Going back to our EMU example, this naturally includes EMU affiliates and the general public who have a need to know. There are no massive hurdles to jump over here, just the baseline maintenance of accuracy.
Now, what's really interesting about all of this is the clear, logical step down in access across the three tiers. We move from high risk, where only specifically designated, individually authorized individuals are allowed,
down to medium risk, which opens up to employees and non-employees who share a specific business need, all the way down to low risk, which is accessible to affiliates and the general public. It's a beautifully structured hierarchy of trust and verification.
Which brings us to our final section, safeguarding institutional integrity. We've seen the matrix, but we really need to tie this whole narrative together. Why does implementing this highly structured matrix actually matter for business leaders and data managers?
So, the crucial point boils down to 4 practical steps. This is the exact procedure a business takes to actually apply the concepts we've unpacked today. First, you have to determine your data volume and types. Basically, understand what you're holding. Second, rate the likelihood of hacking and the inherent sensitivity of that data. Third, assign that data strictly into the high, medium, or low risk tiers. And fourth, classify and safeguard that information according to the specific rules of its tier. By doing this, an institution transforms a chaotic ocean of data into a highly organized, easily defensible structure.
I want to leave you with a final provocative question. If your firm's data was compromised tomorrow, would you know exactly which tier required your functional security module representative's immediate attention? If you don't know the answer, your data just isn't categorized effectively. This matrix isn't just a theory. It is the blueprint for institutional survival in a data-driven world. So evaluate your own data structures, apply these concepts, and make absolutely sure you know where your highest risks truly lie. Thanks for joining me on today's Explainer.